Hello everyone. Today I'm gonna try to make a tutorial video in which I will try to explain to you how to solve a boundary value problem. In this example, I'm gonna focus myself on the boundary condition. The boundary value problem that we are trying to solve is restricted on an interval from A to B. The boundary condition at A is 0. The boundary condition at B is 0. L is the operator. F is the source term. The source term is the function that doesn't depend on U. In this problem, U is the unknown and F is the source term. To solve this problem, we have three steps. The first step is to try to find the basis of the solution space. In order to find the basis, we need to solve the eigenvalue problem. We take this operator L, we try to find a function phi n such that there is a number lambda n. With these two numbers lambda n and function phi n, you have L of phi n plus lambda n. Phi n is 0. You have the boundary condition phi n of A is equal to phi n of B is 0. The first equation is again on the interval AB. And there are two cases. If the operator L is self-adjoint, then this phi n will form an orthogonal basis because you take the inner product of the two eigenfunction phi n and phi m is gonna give you 0. The second case is the case where L is not self-adjoint. Then you have to find a new weight W such that the weighted inner product will make phi n, phi m orthogonal. After you have the basis, you're gonna expand the function fn, the function f, in terms of the basis phi n. So f will be the sum from n is going from 1 to infinity of fn phi n. The coefficient fn can be computed by taking the inner product of f and phi n dividing by the inner product of phi n and phi n. Right? So this is in the case where you don't have the outer adjointness. Then you're gonna have to divide the inner product of fn and phi n to the inner product of phi n and phi n. Right? Remember that in this case you have the weight W. The solution will be un and times phi n, and you have to take the sum when n is going from 1 to infinity. Phi n is given. Un can be computed by dividing fn and lambda n. Now let us try to understand these three steps using two examples that we consider already in our class. The first example is example 2.3.5 in lecture notes. You have uxx plus fx is 0. The interval that we are considering is 0 to L. In this case, f is the source because it doesn't depend on U. ux is the operator because it depends on u. We consider Dirichlet boundary condition because we expect that the solution u will be 0 at 0 and the solution u will be 0 at L, right? In this case, the operator is the term that contains u, which is uxx. The source term is this function f. Now, what is the eigenvalue problem? The eigenvalue problem will be u phi n second. Phi n second is coming from this operator L, right? So you will try to find a function phi n such that phi n second, such that there exists a real number phi n, lambda n, such that when you take the second derivative of phi n plus this number lambda n, phi n, you will get 0. Again, you have to have the same boundary condition between the eigenvalue problem and the boundary value problem. For this problem, by computation like we did in class, we can find lambda n to be n pi over L square, and phi n will be sinus of n pi x over L, which means that when you take the second derivative of phi n, you will get minus lambda n phi n. In this case, the basis will be phi n. We can check that this operator L is self-adjoint. So you can expand f in terms of fn times sinus of n pi x over L. Fn can be computed by dividing the inner product of fn and sinus and the inner product of sinus and sinus. And after you do the computation, you get this formula. Now, the final step, you write u as un times phi n, and this un can be computed by dividing fn by lambda n. Fn is 2 over L, the integral from 0 to L of fn sinus of n pi x over L. And lambda n is n pi over L squared. Now let us consider the second example. The second example is also an example that we considered in class. In this case, you have to solve this boundary value problem. V is a function of t. So the second derivative of v, meaning that you take two derivatives in v on t, right? So t is the variable, v is the function that you have to find, f is the source term. You have the Dirichlet boundary condition. You have to find, this is v, this is v, this is v here, and this is v here. So you have to find a function v such that when you multiply t squared to v second plus tv prime plus f, then is 0. F is a source term that doesn't depend on v, such that v at 1 and v at e will be 0. And this equation is on 1 to e. Now, the operator will be the term that contains all the v. So the operator will be this guy. F is just the source term because it's given. Now, again, we have the same step. The first step is to try to find the eigen functions and eigenvector you're gonna try to solve t squared phi n second plus phi n prime plus lambda n. Lambda n is also a number that you need to find. Phi n is 0 with the two boundary condition. Dirichlet boundary condition, both 0. For this one, after some computation that we did in class, we find lambda n is this guy and phi n is this guy. Now, the key step here is that the operator L is not self-adjoint, right? So we require you that here, after you find the eigenvalue and the eigenfunction, if the operator is self-adjoint, all of the eigenvalue and all of the eigenfunctions are orthogonal. In this case, it is not self-adjoint, so you have to find this weight W such that phi n and phi m are orthogonal in terms of this W. So how do you find this W? This is the key. You write the operator. This is basically the form of the operator, right? Now you divide by W, and here you multiply with W. So it is still that operator, right? You consider the coefficient of V second, and you consider the coefficient of V prime. You're gonna set the derivative of the first coefficient to be the second term, right? Now the questions become solving this equation. This is a first order differential equation that you can solve by using separable method, right? This you can find in one of the tutorial video. We can find that W is 1 over T. So the new inner product with the new weight 1 over T will be this one. You multiply two function f and g, and you multiply with the weight, and you integrate them. What you do now is the following. You expand f in terms of the new eigen function. So the coefficient f can be computed by multiplying fn and phi n in the new inner product, and then you have to multiply phi n and phi n in the new inner product, right? So phi n in this case will be sinus n pi log t. So you replace sinus n pi log t into the formula, right? The Wt in this case will be 1 over t. So the solution will be Vn times phi n, and you take all of the sum. But Vn will be Fn over lambda n. Lambda n is computed right here.